Imagine this. It's a hot and sunny Saturday morning and Tim wants to practice his soccer. He heads to the field and stands in preparation for some free kicks. But Tim isn't very great at soccer, so he needs you to help him. Tim knows that on average he makes his free kicks at a 40.5-degree angle, and from his niche knowledge of the sport, he also knows the standardized height of a goal is 2.44 meters. If Tim sees he's standing 47.3 yards from the goal, how fast must Tim kick the ball so that it lands in the goal, just barely missing the top? In other words, this problem is asking us to find a velocity such that when the ball travels to the goal, it is at a height of 2.44 meters. First, we know that the horizontal component of velocity multiplied by the time it takes for the shot to reach the goal must be 47.3 yards, which converts to 43.2 meters. Next, the vertical position is given by a kinematic equation. Taking the change in position to be 2.44 meters, we have vertical component of velocity times time subtracted by 1/2 the acceleration times time squared equals 2.44 meters. Now we have two equations and two unknown variables, so we may solve the system of equations. From the first equation, time is equal to 43.2 meters over the horizontal velocity. Next we substitute that value into the second equation. Simplifying, we have 43.2 meters times tangent of 40.5 degrees subtracted by 4.9 meters over seconds squared times 43.2 meters over horizontal velocity squared equals 2.44 meters. Now we can isolate velocity. I'm going to drop the units as they get fairly messy, and they've already served their purpose. Note that I'm also taking into account the significant figures on the 1/2 times acceleration term. After solving for v, we get that Tim must kick the ball so that it gets a speed of 22 meters per second.